Okay, so welcome to this video. We are going to be looking at discrete random variables. Okay, so we're going to talk about everything that concerns discrete random variables. So meaning from the definition of what the discrete random variables are. Okay, we're going to explain what they are. And with me, I have a tutorial sheet here with a set of questions, okay, on discrete random variables. So there are like 10 questions in the tutorial sheets, and they're going to cover all the concepts that you have to know. Okay, so we'll talk about the probability mass function, talk about the commutative distribution function, how to find their non-probabilities, how to check if a certain PMF is actually a PMF. Okay, so we just check that by making sure that all the probabilities actually sum up to 1. Okay, so these are the questions here. We're going to look at how to find the expectation, which is the mean, and also how to take the expectation of linear transformations. Okay, how to take expectations of functions like y squared and the like. We're going to look at them, how to find the variance, and also the linear transformation of the variance. Okay, from that, we'll look at how to find the probabilities. We'll look at also independent random variables, as we'll be solving all these questions that you can see here. Okay. All right. Another thing that we'll look at is actually the binomial distribution. Okay. That is just a discrete distribution, right? So look at it in full. So how to find the probability for a binomial distribution, how to find the mean, and how to find the variance. Okay. So we'll also look at some questions where we're trying to model the assumptions for the what? For the binomial, and we'll look at the normal approximation to the binomial. So let's say your sample size is very large, like n is 100. How are you going to handle that? Okay, we'll see that we're just going to use the normal approximation to the binomial. Okay, and then we're also going to look at the Poisson. Okay, apart from the binomial distribution, look at the Poisson distribution. And the last thing will just be constructing probability functions. Okay, so you can see here that 10 questions. All these questions here are going to be solved, and full videos will be available on the website, which is discretelearning.com. Right, so now let's start from the first question here, and then we'll move like that. So in this lesson, we are going to look at discrete random variables, okay? But before we even do that, let's define what a random variable is. Okay, so by definition, we say that a random variable, okay, is simply, we're going to say an attribute or a characteristic, okay, that is being measured, in an experiment. Okay, so this is what a random variable is in simple terms. It's just an attribute or an experiment or a characteristics, okay, that is being measured in a what? In experiment. Okay, so this random variable is usually represented or denoted by a symbol. So we can say X or maybe Y, okay, or Z or whatever symbol, let's say this symbol here, okay? So this random variable can be denoted by a symbol or a letter. Okay, so there are two types of random variable. There's one, what we are going to talk about today, which is a discrete random variable. And then there's another one, which is a what? A continuous. Okay, so how do you identify that this one is a discrete and then this one is a what? A continuous. So for a discrete, you're going to be given, okay? You're going to be given distinct countable values that X can take, okay? So we can say X can be 1, it can be 2, it can be 3, and it can be 4. So since these values that this X can take is countable, we call this X as a what? A discrete random variable. Okay, and then later on, we're also going to look at what we call as the continuous random variable. So how do you identify that? You're going to be given a range of values that this X can take. So they can say X, okay, is from maybe, they say 15, from 10 to 15. Okay, so if the X takes values in an interval like this, we're going to say this here is a continuously random variable like that. Okay, but if it's countable like this one, we're going to say it's a what? A discrete random variable. Okay, so in short, we can just say discrete random variable is actually a type of variable that takes on distinct countable values, and it's typically represented by what we call as a probability distribution. Okay, so this probability distribution, it can be represented in two ways. Okay, so the first one is the table form. Okay, you can use the table form to represent the probability distribution, or you can use what we call as the PMF. Okay, so this means probability mass function. So both the table and the PMF, okay, so the PMF is just simply a formula. So we can say f of x, okay? So the PMF is simply a formula. So we're going to say this discrete random variable can be represented in a table form, okay, or a PMF. And that representation, we call it as a probability distribution. Okay. So um, both the table and the PMF, which is just simply a formula, will assign a probability to each possible value of x. Okay. So this PMF, f of x, okay, can also be represented in this way. You can say P of x, okay, or you can say P for the random variable that is equaling a certain value, small letter x, like that. So if you see this and this, they're just the same. Okay. And then in a table form, we're going to represent it like this. Okay, it's just going to be a table that assigns each random variable that you have there, okay, a certain probability. So we can say our random variable is x, and then here we're going to have the probability px. Okay, so we can say we have 1, 2, and then 5. So we can say, okay, this one is 0.2, this one is also 0.2, and then the remaining one will be 0.6. Okay, so we're going to say this one here is also a probability distribution, but it's being represented in a table form. So you can see that each value of the x here takes on a certain probability. Okay, so that's what we call as the probability distribution. Okay, so now it's very important for us to know the properties of the PMF, okay, which is just the probability mass function. So for something to be a valid, okay, for something to be a valid PMF or probability mass function, then it must satisfy the following two conditions. So the first one, okay, is that f of x, which is the probability mass function, should be between 0 and 1, okay, for all the x values that for all the values that x can take in that distribution, okay, the f of x should be between this 0 and the 1. Okay, so this is the first condition. So this simply means that the probability, okay, of anything happening should always be between 0 and 1. You can't have a probability that is more than 1, and you can't have a probability that is less than 0. And then the second one, okay, is that when you sum all the probabilities, okay, for all the values of x that you're considering, okay, the total that you should get should always be 1. Why? Because the total probability can always be 1. Okay, so for example, if we say the probability of you passing a test, okay, is 0.5. So this is the probability for passing. Then it means the probability for failing should also be 0.5. So that when you add here, you should get 1. So that's what we mean. When we add the probabilities, okay, of all the values that x can take, we should always end up with 1. Okay, so it's very important to know these two because we are going to use them, okay, to answer questions. Okay, we are going to use them to answer questions. All right, and then the other thing that we need to know is how to calculate the expected value, the variance, and standard deviation, as well as the cumulative, how to calculate the cumulative probability. Okay, so the cumulative probability is actually represented by a capital letter F like this. Okay, so we're going to say capital letter F of x. So the cumulative distribution function, okay, whenever you see such, it's called the cumulative distribution function, is just a function, okay, that describes the probability that a random variable, okay, will take on a value less than or equal to a given value. So in other ways, we say that f of x, okay, capital F, always put capital F here, is the same as the probability, okay, that this random variable x will take on values, okay, that are equal to this x or less than this x. That's the cumulative distribution function of the cumulative distribution probability, okay? So we are not considering one probability, no. You are considering the probability, okay, for some certain values that are less than or equal to a certain value. So for example, I'll put it in a table, okay, so that we can easily understand. Okay, so I'll say this is my random variable x. I have 1, I have 2, and then I have 3. And then this is my probability here. Okay, and then I say this one has the probability 0.5. This one has 0.1. Okay, it means this one will have 0.4. So that the summation should always be 1. Okay, and then the f of x here, which is the cumulative distribution function, okay, or the cumulative probability, will be, okay, the probability that x takes on a certain value or less than that. So the first one here, just get the same one, this one here. So we're going to say this is 0.5. And then the next one here, the cumulative distribution, will be this 0.5 plus 0.1. So it will be 0.6. Then the next one to be 0.6 plus 0.4. So the next one will be what? 1. Okay. So this also tells us that the total cumulative probability should always be 1. Okay. If you find any other number here at the end, okay, just know that you've gone wrong somewhere, because the total cumulative probability should always be 1. So that's what it means here. It means this x value is taking, okay, the probability at a certain value of x, but also considering all the value of x that are less than it. Okay, so for example here, if they told you to find f2, f2 will simply be the probability that x is less than or equal to what? 2. So how many random variables here are less than or equal to 2? We see there's 1 and 2. So this one is the same as the probability of 1 plus the probability of what? 2. So when we add them there, it's 0.5 plus 0.1. That is this 6 that we got there. Okay, so that's how we are going to be finding the cumulative distribution function or the cumulative probability. Okay, and then the other thing, now we have to know how to calculate the we have to know how to calculate the expected value, okay, and the variance. So the expected value is simply the average, okay? You know how to find the average, right? For example, if I have 10, 20, and then 30, then I tell you to find the average of this, okay? You're just going to say the average there is equals to 10 plus 30 plus 20, and then I divide by how many they are. 1, 2, 3. So 3. Okay, and then you find whatever you find here. So this average here, under discrete random variables, we're going to be calling it as the expected value of x. Okay, so you're just simply finding the mean or the average. Okay, so under probability, we're going to say that the expected value of x is simply equals to, okay, the summation of all x multiplied by the probability, like that. Okay, so here you can write OX. So for all the x values that we're considering in this situation, okay, so you multiply x with the probability that it has, and then you add them. So simply meaning that if we had something like this formula means this. Okay, so if this is my x and then this is my px, remember I said px is the same as f of x, right? And then I have my probabilities here. Let's say for 1, 2, and 3. And then here I have 0 0.5, 0 0.1, and then 0 0.4, if I have something like that. So the mean there will just be multiply the x with its probability, and then plus multiply by x with its probability, multiply the x with its probability. So we're going to say 1 multiplied by 0 0.5 plus, okay, 2 multiplied by 0 0.1 plus 3 multiplied by 0 0.4. So when we add all this, we're going to get what we call as the expected value, okay, or the average. So this is the formula that we are going to be using when finding the what? The average, okay, or the expected value. And then we can also talk about the variance. Okay, so the variance, we're going to say variance of x is simply equals to the expected value of x squared minus the expected value of x, and then we square it. So notice that here the square is inside. It is with the x, but here the square is outside. Okay, so it means when you're finding the variance, you first of all have to calculate, okay, the expected value of x by this formula that we can see here. Okay, and then from there you have to calculate the expected value of x squared. So how do we calculate the expected value of x squared? Okay, we are going to say expected value of x squared is just equals to the summation, okay, under all the x values that we are considering of x squared multiplied by f of x. So this is the formula that we're going to be using. Okay, so we just replace where those x here, now we put x squared, as you can see there. Okay, so when you find that value, put it here and then minus the value of the expected value of x that you found, and then you square it, and then it's going to give you the variance. Okay, and then from there we can talk about the standard deviation. So the standard deviation is not difficult. Okay, so standard deviation, as long as you have the variance, okay, then you have your standard deviation. So standard deviation will just be the square root of the what? The variance. Okay, so those are some of the things and rules that you need to be aware of as we are tackling these questions here. So now let's look at some sample problems. Okay, so we start with this one. So here they're saying um, the discrete random variable x has the probability distribution given in the table below. So we can see the table here. We have the random variables there with their probabilities. Okay, so question 1 or question A, write down the values of f5. Okay, so remember, if I have fx, it's the same as p of x less than or equal to a smaller letter x. So this smaller letter x here is the one that represents these two numbers on top here. Okay, so what we're going to do there now is, okay, we're going to write f of 5. So f of 5 will simply be equals to the probability that x is less than or equal to what? 5. Okay, so it means we are adding all the probabilities for all the x values that are less than what? 5. Okay, so minus 2 is less than 5, 1, 3, and 4. So we're going to add the probabilities for these guys. Okay, so the probability of minus 2, or maybe first I should write probability of minus 2 plus the probability of 1 plus the probability of 3 plus the probability of 4. Okay, so I end on 4 here because this 6 is not less than 5. And then I add them now. So the probability of minus 2 is 1 over 4 plus probability of 1, 1 over 6 plus probability of 3, 1 over 3 plus the probability of 4 is just 1 over what? 12. Okay, so these are fractions. You should be able to add them. So when you add all these fractions, you get 5 over 6. Okay, and then when you put this number in decimals, you're going to get 0.833, like that. So this here will be the F5 or the cumulative probability of what? 5. All right, and then the other one there is find the probability of 5. So there now, it's not the cumulative probability, okay? It's just the probability. So the same probability of 5. Okay, so can you see any 5 on these random variables there? No, we can't see it. So it means the probability of 5 there would just be 0 because we can't see it there. Okay, so the probability of 5 is 0. All right, we go to B. So B, we have that. Okay, B, we have that. Okay, let me get this one. So B, we have that find the expected value of X. Okay, so remember expected value, we're just adding the product of this plus 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 the product of this. So we're going to say expected value of X will be equals to, okay, to be minus 2 multiplied by 1 over 4 plus 1 multiplied by 1 over 6 plus 3 multiplied by 1 over 3 plus 4 multiplied by 1 over 12 plus 6 multiplied by 1 over 6. Okay, so this is what we have. Okay, this is what we have. So here we are going to get minus 1 over 2. Here we're going to get plus 1 over 6. Here we are going to get plus 1. Here we're going to get plus 3 over 4. Plus here we're going to get 1. Okay, and then from there we can try to add. Okay, so 1 plus 1 is 2, and then we can add these other fractions here. Okay, so the common denominator will get 6. I'm adding this, this, and this. So I'll get 6. So 2 into 6 is 3, multiplied by minus 1, I get minus 3. This one into there, it's plus 1. Okay, so this is wrong here because 4 cannot go into 6. Okay, let's use another common denominator. So let's say the common denominator is 12. Yeah, this one will work. So 2 into 12, it's it's 6, and then multiplied by minus 1, minus 6, plus 6 into this is 2, 2 multiplied by 1, 2. Then 4 into 12, it's 3. 3 multiplied by 3, it's plus 9. Okay, so what are we going to get here now? Okay, so we are getting this 2 minus 6, we are going to get minus 4 plus 9, okay, divided by 12. So this is going to give us what? This is going to give us 9 minus 4, it is 5 over 12. Okay, so it's giving me 5 over 12, and then I add this 1 and 1, so plus 2. So what are we going to get there? Okay, I think let's redo this. I feel like we've gone wrong somewhere. Okay, so we have minus 2 over 4. Okay, I'll write it as minus 2 over 4. Here we have plus 1 over 6. Here we have plus 3 over 3. Okay, there we have plus 4 over 12. Then there we have 6 over 6. Okay, and then let's add these now all together. So we're going to say common denominator is 12. So 4 into 12 is going to give me 3. 3 multiplied by minus 2 is going to give me minus 6. 6 into this is going to give me 2, plus that to be plus 2. This into this, it will be 4. Okay, 4 multiplied by 3, I'm going to get what? Okay, 4 multiplied by 3, I'm going to get 12. And then 12 into this is 1 multiplied by 4, I'm going to get 4. And then 6 into this is 2 multiplied by that, I'm going to get, okay, I'm going to get what? 6 into this is 2, I'm going to get 12. Okay, so now let's add these things. So this is 4 plus 2. Okay, I'm going to get 6. And then that 6 minus the 6, I'm going to get 0. So I'm just remaining with 12 plus 12, which is 24. And then divided by another 24. So this will give me 2. Okay, so that one now is the correct answer. So it means the expected value, you can write it here, of x, we're just finding what? 2. Okay, and then we look at C. C, they're saying find the variance. So remember the formula for the variance. We said the variance of x is equals to the expected value of x squared minus the expected value of x, and then we square it. So the expected value of x, we already have it there. So we just want to find the expected value of x squared. So we're going to say expected value of x squared is equals to, okay, minus 2, okay, squared. Because you square the random variable, don't square the probability. Multiplied by 1 over 4, plus 1 squared multiplied by 1 over 6, plus 3 squared multiplied by 1 over 3, plus 4 squared multiplied by 1 over 12, plus 6 squared multiplied by 1 over 6. So this is what we get, okay, when we square. So it means here we're going to have 4 and then 1 over 4. Here we still have 1 and then 1 over 6. And then there we still have, we have 9 and then 1 over 3. Okay, there we have 16 and then 1 over 12. and then here we have plus 36. Okay, and then in the brackets we have 1/6. Okay, so we have to add all these fractions here. Okay, and then find the final answer. So I'll just do this on my calculator to save some time. Okay. All right, so my calculator, when I punch in all these guys, it's giving me 11.5. Okay, so it means the expected value of x squared is simply 11.5. Okay, so once we have the expected value of x squared, it means we can find the variance. So variance will be equals to the expected value of x squared, 11.5, minus the expected value of x, which is 2 squared. So this will be 11.5 minus 4, which will be equals to what? Okay, this will be equals to 7.5. So 7.5 will be our variance there. Okay, so we can write it here. We say variance of x is actually equals to 7.5. Okay, because we'll need it in the other questions. All right, so now let's solve D. Okay, so D, we are finding the expected value of a linear equation. So they're saying expected value of 7 minus 2x. So how can we deal with this? Okay, so we have some properties that we need to know. So whenever you're given the expected value, okay, of ax, a can be any number and then plus b, something like that. Okay, so what happens here is that you distribute this e to the a, x, and the b. So we're going to say expected value of ax, okay, plus the expected value of b. So whenever you're finding the expected value of a constant, because b and a here are constant, x is the one which is a variable. Whenever you're finding the expected value of a constant, it's just that same constant. Okay, so I'm going to say this expected value of b is just b. Okay, and then here you factorize the constant, or you take the constant in front. So it's going to be equals to a, and then you remain with the expected value of x. Okay, so whenever we have such a linear combination there inside, we are going to expand it like this way. Okay, so following this same thing, I can rearrange this and I'll say this is the expected value of minus 2x and then plus 7. So you see that in this form now I have ax plus b. So the b is the what? 7. And then the a is the minus 2. So what is the expected value here? To just be expected value of minus 2x plus the expected value of 7. So this one is a constant, so it will just be 7. Then this one, the minus 2 will go in front, so it will be minus 2. Okay, and then the expected value of x. So expected value of x is 2. So I'm going to write 2 here. So what we have is 2 multiplied by the minus 2 outside there, which is just minus 4, and then plus 7. So it means the expected value, okay, of this linear function, which is 7 minus 2x, will just be 3. Okay, so always remember this property here when you're dealing with the expected values. And then I can also see there's the variance there, okay, the variance of a linear function. Okay, so it also has a special rule that we have to follow, okay, when finding the expected value of the variance of a linear. So whenever you have the variance, okay, of maybe ax plus b, okay, you can say this here, this one here is the same as, okay, we expand this as, we bring this a in front and then we square it, and then we say the variance of x, okay, plus the variance of b. So now, the variance of a constant is always 0. Okay, so this part here, when you look at the formulas in the books, it won't be included. Okay, they will just say the variance of a linear factor like that one, okay, is just equals to a squared multiplied by the variance of x. Okay, so this is what we're going to use. So I'm going to write this one here in this form. So I'm going to say the variance, okay, I'll start with the minus 2x and then plus 7. Okay, so this one is the b, this one is the a. So let's square the a, which is the minus 2 squared, and then variance of x. Okay, and then plus the variance of 7. So variance of a constant is always 0. Okay, so maybe I should not write it that way. I'd say this one is always 0. So what we remain with is just 4 multiplied by the variance of x. But remember, the variance of x, we found it was 7.5. Okay, so when you multiply that 4 multiplied by the 7.5, you're going to get 30. Okay, so this is the variance of 7 minus 2x. Right, so that's the rule that you use there. Okay, and then let's look at F, okay, which we're just finding the probability there. Okay, so they're saying F, find the probability that 7 minus 2x is greater than x. Okay, so what you do here is solve what you have inside. Okay, so put the like terms together. So this one will be 7 is greater than, then the 2x, we take it that side like this. So this will be probability of 7 greater than 3x. Okay, so now our random variable is x and it's not 3x. So we have to divide both sides by the 3. Okay, so what we end up having is this. We have the probability that x is less than, okay, 7 over 3. Okay, right, so this one here is going to be equals to the probability that x is less than. Okay, so you punch that 7 over 3 on your calculator. It's going to give you approximately 2.333. Okay, something like that. So it means here we want the probability that x is less than 2.33. Okay, so what values here are less than 2.33? So we're going to say this is the same as the probability of minus 2 because it's less than this, okay, plus the probability of 1 because it's less than this. So we can't include the probability of these 3 here, no, because it's not less than 2. So let's just add the probability of these 2, then we'll be able to find our desired probability there. So we're going to say this is equals to, the probability of minus 2 is 1 over 4, plus the probability of 1 is 1 over 6. So we can add this. Okay, common denominator there will be 12. So 4 into 12 is 3. So I have 3 plus, then they have 2. Okay, so this one here will be 5 over 12. So you can punch this into your calculator. You're going to get approximately 0.41667. Okay, so this is the probability that 7 minus 2x is greater than x. All right, so we are done with the first problem. Okay, so now thank you so much for watching. If you'd like to access the full video solutions to all the questions in this tutorial sheet, okay, they are available at discretelearning.com. So you can visit discretelearning.com, you're going to find them. Okay, so actually we do offer supplementary lessons for all the courses that you can see here. So there's biology, there's physics, there's chemistry, and there's mathematics for both semester 1 and semester 2. So you can subscribe for any of those courses, and what you're going to access is full videos for the tutorial sheets, full videos for the assignments, full videos for the quizzes and the tests, full quizzes for the final exam papers. Okay, and also you can consult from us at any particular time that you want. Okay, and then apart from that, you're also going to access live classes. So we do have some live classes where we interact with the students. Okay, you're also going to be able to access that once you subscribe. So you can contact us on these numbers that I've put there. Okay. All right. So if you've never seen actually our website, let me just show you here. Okay. So just go to Chrome and then type in discretelearning.com. So you've seen there discretelearning.com, and then you just click search. So the website should come up, okay, once you click the search button there. So let's just wait for it to load. Okay, so you can see this is a website here. So if you do not have an account, it means it will take you to the login page where you have to create the account, right? So you create your account, you put your details there, like your name, your email, and then you set a password for your account, okay? And then use those same details to log in. So once you log in now on the website, this is what you see. So you can see there's math, chemistry, there's physics, there's biology. Okay, so you can subscribe for any of the courses that you need help with. Okay, so if, for example, you need math, just go there, click on the course math, okay, and then just wait for it to load. Okay, so this is the mathematics course. So it depends at the university where you are. So if you are at any other university, you go in the general mathematics folder to find your things. If you're at Apex or Unilas, you use these folders here that have been named Apex or Unilas. Okay, so those questions were for Unilas second semester. So you just come here and then you open the folder for the second semester. Okay, then you wait for it to load. Okay, so once the folder opens, you can see topic lessons, summarize notes, tutorial sheets, and then past quiz test and exam papers there. So if you want the videos for the tutorial sheets, you just click there to open the folder for the tutorial sheets. Okay. Okay, so now you can see in the tutorial sheets and assignment folder, you can go in this folder, videos, video solutions. Okay. Then you just wait for it to load. Yeah, so it's loading there. And then you're going to find all the tutorial sheet there that have actually been solved. So you can access this at any particular time, as long as your subscription is active. So you can see from the assignment 1 all the way to tutorial sheet 7, which will be your last tutorial sheet. The videos are already there waiting for you. So you can learn with these at your own time from anywhere. Okay, you can learn at your own time from anywhere. So now, if you'd like to contact me, okay, my number is 0779 96 40 and then 10. So that is Twitter Post Solutions. Okay, so if you'd like to subscribe, you can check the link in the description below here. Okay, there is a video registration guide that's going to guide you on how you can actually what? Register. Right, so thank you so much. This has been Twitter Post Solutions. Until next time, always there for you.